I'm going to go over a little lesson on how to change degrees to radians today. And we learned in class with a little example, we cut out some circles and we fold them into where we could see the radius, and we measured how many of the radius would mark up around the whole circle. And we ended up between 6 and 6.25 and 6.5. We eventually realized that it's something to do with pi, and it ended up being that there were 2 pi of the radius that could be marked all the way around. So that would be 2 pi radians. 2 pi being 3.14 with another 3.14, so about 6.28. But to be exact, 3 pi can be 360 degrees can be 2 pi radians. So using some simple proportions, if you have half as many degrees, 180 degrees, that will be half as many radians, which would be pi radians. So that means there's a little bit more than 3 of the radius that could work for that problem, 3.14, and so forth. So when we go to 90 degrees, we can still just use proportions. That'll be half of that. That'll be pi over 2, or 1/2 pi. Notice that you don't write your answer like that. We want to make sure it's 1/2 of pi, so we want our answer to be written like this. Or we could write our answer as pi over 2. So that'll be matching up our 90 degrees. For the next one, for 60 degrees, it might be a little bit trickier to get there. You could use the 180 and think about how do you get from 180 to 60. And that would be dividing by 3. So I could take this and I could divide it by 3. And so I would have pi over 3 radians. There's a couple other ways to get there, and I'll show you a few more ways in a second. In order to get to 45 degrees, that's going to be half of our 90. So if you have pi over 2, taking half of that would become pi over 4. And that would match up to 45 degrees. Now, watch what's happening over on the right side here. I want you to just be careful. Like we're going from pi, which is pi over 1, to pi over 2, to pi over 3, to pi over 4. Are we going to go to pi over 5 next? Not necessarily. These are just some random degrees that I picked. They're not going in order by scale or anything. It's not constant pattern. You can see from here we're decreasing 30, here we're decreasing 90, here we're decreasing 15. So the pattern that I have is not necessarily a linear pattern. So when I go to 30 degrees, I could maybe use the 90 degrees and take 1/3 of that. So 1/3 of this is going to go to pi over 6, right? Pi over 2. Cutting the third is going to be pi over 6. To write a better pi. So I wanted to show an example. If I didn't have any of these to work off of, how could I just work with 135 degrees? And that's what I'm going to use for my example. So we know up above that 180 degrees is 1 pi. That's kind of like 12 inches equals 1 foot, right? It's something that we know that's standard, that's constant, that happens all the time. It's proportional. It's a conversion rate. So I'm going to go ahead and use this, and I'm going to use the idea of stoichiometry in chemistry to cancel out units. So I'm going to go ahead and use a fraction since it's proportional, and I'm going to take this 180 degrees and show that it is equivalent to pi and use a fraction. So the same way I could write 12 inches is 1 foot, and then if I add 5 feet, I could just cancel out the feet, and 5 times 12 would give me the number of inches, so 60 inches. We use that same concept for doing degrees to radians. So I'm going to use this fact of 180 degrees leads us to 1 pi. So I have 135 degrees, and in stoichiometry you want to cancel out units. So I'm going to use the 180 degrees, and I'm going to put that on the denominator so that my degrees can cancel out my degrees. And the same way that 1 foot is equal to 12 inches, I see that 180 degrees is equal to 1 pi. So I'm going to set that up over here. Now when I multiply this on the calculator, 135 times pi divided by 180 is going to give me a weird decimal. That's okay. but that's probably not the answer that I want. So what I'm going to do is I'm just going to simplify the numerical part of this. The 135 divided by 180. I'm going to keep my answer in pi, units. So 135 divided by 180. And I know I want this as a fraction, so I'm going to hit math and turn the answer into a fraction. So here I have 3/4. That tells me how many pi there are because I didn't type the pi in. So this is equivalent. Okay? This fraction right here is simplified to 3/4. And then I still have the pi on top, so I'm just going to carry that over and put that again on the numerator. So I have 3/4 pi for the number of radians that I have for 135 degrees. And I can prove this too. I can type in 3 pi over 4, and it will give me that 2.35 number that I got previously on the calculator. So I just use a little stoichiometry to turn the degrees into radians. And I'm going to go ahead and do that for another one of the examples. Like I'll go ahead and use one of the ones above that I did. Like I'll go ahead and use the 60 degrees, and I'm going to come down and prove that the 60 degrees is equal to what we did before. So if I take my 60 degrees and I use the fact, the mathematical fact, the constant, that I know 180 degrees is equivalent to pi. It's just like doing feet over inches, okay? 1 foot over 12 inches, or 12 inches over 1 foot. Right, so I'm just using the stoichiometry to cancel out degrees over degrees. And I can type this in, but I know that 60 over 180 is going to be equal to 1/3. I can prove it. 60 divided by 180. Math, turn it into a fraction. 1/3. There's your 1/3 in the circle. And so 1/3. And then pi is still in the numerator, so I'll bring that over. Pi is still in the numerator, so I have 1 pi over 3. That is the same exact thing that we had up above. So I just need that one fact. I just need the one fact that 180 degrees is equal to pi, and I can just cancel out my units and use stoichiometry.